So we have the function f of x equals x cubed, and we want to know what the derivative of this is. So the f prime of x. At this stage of the game, all we know is the limit as the delta x approaches 0 of f of x plus delta x minus the f of x over delta x. That's all we know for calculating a derivative. So let's go ahead and do that with this formula. So I'm going to plug in my values. I get the limit as delta x values approach 0 of x plus delta x cubed minus x cubed over delta x. Well, first I have to expand this cubic function, and I'm going to use Pascal's triangle to do it. So a is x. I have 1 times x cubed plus 3 times x squared delta x plus 3 times x delta x squared plus delta x cubed. Then I have my f of x minus x cubed all over delta x. X cubes cancel, and what I have left is a delta x in every term or more than 1. So I'm going to cancel my denominator with the delta x in the denominator with each term in the numerator. That eliminates the first one. This one becomes just delta x to the first power, and this reduces to delta x squared. So now I've got 3x squared plus 3x delta x plus delta x squared. Don't forget your limit. All right. Now, if I plug in 0, I don't have a problem with 0 in the denominator anymore. In fact, I'm going to lose 2 of my terms. 3x squared times delta x times 0 is 0, and 0 squared is just 0. And so my derivative is 3x squared. Now, that was a lot of work. It wasn't crippling, but it was a lot of work. And it turns out that there's a great shortcut for this kind of a derivative. Let's write them down below. I'm going to start with the function f of x equals x cubed, and then the derivative is 3x squared. So there's a really cool shortcut that you can do with power functions. It's called the power rule. For derivatives. And what the power rule says is that if I take the derivative of a function involving a variable to a power, I can just take the power out in front, so n times x, to the previous power minus 1. And you can see that that's exactly what happened here. I brought the power down, so I have a 3 in front, and 2 is the same thing as 3 minus 1. So let's do another. We have the constant rule. The constant rule says that if you want to take the derivative of a constant, it equals 0. But let's look at why. I think this one needs a little explaining as well. So this would be the graph of a constant function at c. And if I choose an x value, the y value that associates with that x value is c. If I choose an x value that is delta units away, some other x value, the output is c. No matter where I choose, the output is going to be c. So if I use the limit definition of a derivative, Then insert the values I just discussed. The f of, or the function of, x plus delta x, that's this value here, that's c, and the f of x is also c. Well, it's still a limit. Then c minus c equals 0. I never actually have to go to 0 in the denominator because the limit approaching from both sides equals 0. And so we have a constant rule that tells us that anytime we have a constant to work with, we can just take the derivative equals 0. So let's put the two of these together and calculate the derivative of f of x equals 3x to the 5th plus 7. Darn it, I have to give you another rule first. So there's another rule called the sum and difference rule. And this one says that if you're calculating the derivative of two functions that are added or subtracted, so the f of x plus or minus the g of x, then you can take the derivative separately. So this is exactly the same thing as taking the derivative of f of x and then adding or subtracting whatever the derivative of g of x is. Okay, so now we have enough to do this one. We have the f prime of x equals, well, here's the sum, right? It's a sum of two different functions, so I can do them separately. So it equals the same thing as the derivative of 3x to the 5th plus the derivative of 7. Well, the derivative of 3x to the 5th is, darn, I still don't have enough to tell you. Let me show you another rule. Okay. So there's another rule called the constant multiple rule. It's such a good idea to write the lesson this way. When it was in my head. Okay, so the constant multiple rule says that if you're taking the derivative of some constant times some function, that you can take the constant out front and multiply the derivative of the function by that constant. Let's see if I have enough rules now to do this one tiny problem. All right, so the constant multiple rule says that if you're multiplying by a constant, you can just pull that out front. So in this case now, I've broken them apart. I've used the sum and difference rule to separate them into two separate derivatives. Now I've got to separate this one because this is a constant. I have a 3 out in front of the x to the 5th. So I'm going to pull that 3 out front and then take the derivative of x to the 5th, and then I'm going to add to that the derivative of 7. I think I'm there finally. So that's 3 times, well, what's the derivative of x to the 5th? I'm going to use the power rule for that. 5 comes out front, x to the 5 minus 1 is 4, plus the derivative of 7, well, that's 0 because that's the constant. The constant rule, the derivative of a constant rule. Then I can simplify. 3 times 5 is 15, x to the 4th. Finally, done. And one last set of rules for this section is the sine and cosine rules. The derivative of sine x equals cosine x. Wow, couldn't be easier than that. And the derivative of cos x equals the opposite of sine x. Okay, so let's do some examples. Let's play around with these rules and see what we can come up with. All right, so let's calculate the derivatives of each of these. Well, this first one is a variable with an exponent, so I want to use the power rule. And don't let the -7 throw you. It works exactly the same regardless of what the power is. So the f prime of x equals, bring the -7 out front, and then x to the -7 minus 1. So it's going to be -8. Derivative finished. The next one, in this case, we don't really have something to help us find the derivative of the denominator if the power's in the denominator. So we're just going to rewrite this. It makes sense to turn this into x to the -2, and now it's exactly like the previous example, where the derivative of this function is -2x to the -2 minus 2 minus 3. Same thing here. We've already handled what we do when there's a power in the denominator, but I have another number out front. Again, we're just going to rewrite this. I'm going to turn this into 2 as a constant and then multiply that by x cubed, or 1 over x cubed, which is the same thing as saying 2 times x to the -3. Now that I've rewritten it, super easy to find the derivative. So 2, constant multiple rule, and then times -3 x to the -3, take away 1, minus 4, or -4. And now clean it all up. -6 x to the -4, or if you prefer, -6 x to the 4th. So one more just for the fun of it. What the what? All right, first, breathe. Don't be too panicked, and notice that I actually have plus signs and minus signs, which means I could use the sum and difference rule and treat each of these separately. Okay, so let's do that. So the derivative of x equals, let's take the derivative of the first one. I have the constant multiple rule, so I can take a 2 out front, and then take the derivative of the power using the power rule. So that's 2x to the 2 minus 1, done. Plus, well, this one I want to rewrite. I don't like 5x, 5 halves, 5 over 2x cubed. So I'm just going to rewrite this as 5 halves times x to the -3. So I've pulled the 5 halves out front to make it a constant multiple, and then I brought the x cubed into the numerator so it has a -3 power. So now constant multiple rule, and then the derivative of x to the -3 is just -3 x to the -3 minus 1 is -4. Minus, well, cosine, the derivative of cosine, remember the rule? Cos x equals minus sine x. Plus 3 sine x. Well, constant multiple rule, I've got a 3. And then sine x, derivative of sine x, cos x. Minus 8. But 8 is a constant, and the derivative of any constant is 0. Let's clean it up. 2 times 2 is 4x, plus, minus 5 times 3 is 15 halves, x to the -4. I actually prefer my x in the denominator with a positive exponent. Minus minus, or opposite is plus, sine x, plus 3 cosine x, plus or minus 0. So this is the derivative of this function.